Welcome back to eJournal Club, where we read one recent paper together and leave it open for you to discuss. Today's study is about drug metabolism during pregnancy, and a tissue the field has mostly overlooked. For years, we've focused almost exclusively on the placenta, but there's more to the story in the membranes surrounding the fetus. The study we are looking at was published by Kammala and colleagues in Life Sciences in 2022. This work re-evaluates the metabolic contribution of fetal membranes compared to the placenta. For years, the placenta has been treated as the main organ that breaks down drugs and toxins before they reach the fetus. It carries the cytochrome P450 enzymes, the family responsible for processing most of the drugs we take. The fetal membranes, the amnion and chorion that surround the fetus, were generally seen as structural tissue. As the authors note, before this work, only one enzyme family had ever been reported there, and its activity had never been tested. So the authors proposed a different view. They hypothesized that the fetal membranes are not just a passive sac, that they express cytochrome P450 genes, and that those genes produce enzymes that actually function in drug metabolism. To test this, the authors used three approaches. First, RNA sequencing to map which enzyme genes are switched on in the membranes. Second, a separate gene expression method to independently confirm those readings. And third, the key step, activity assays. They added specific blocking compounds to see whether the enzymes were doing real chemical work, not simply present as genes. The authors report that the fetal membranes carry almost the same set of cytochrome P450 enzymes as the placenta. With few exceptions, the profiles were strikingly similar. The confirmation method agreed. Each cell layer showed unique profiles, with the major drug-metabolizing enzymes well represented. And in the activity assays, two cell layers showed genuine inhibitor-sensitive enzyme function. The amnion epithelial cells, which face the amniotic fluid, and the chorion trophoblast cells, which are on the maternal side, were both active. A third cell type stayed largely silent. The authors interpret this as evidence that the membranes help decide how much of a drug reaches the fetus. They propose that together these form an active barrier rather than a passive one. These are the authors' interpretations. The conclusion is that the fetal membranes contain a working metabolic enzyme system alongside the placenta. How convincing do you find the step from gene to function? For further details of the article, please go through the full text and discuss in my eJournal community channel in the description. Stay connected and grow together.